Today I just thought we'd take another look inside of this Ego 56 volt lithium ion 2.5 amp hour battery pack. This is the one that I had taken apart and showed the internals of earlier in a previous video. I showed it coming apart and going back together, and the arc lithium cells and things of that nature, and how well the board was potted. So maybe today, just going into it deeper, seeing if we can get to the circuit board, see if we can get through that potting material, look up some of the components and get an idea in troubleshooting. You know, just having some fun trying to learn more about the pack. Maybe help out the community if they're also having trouble with the same type issue with the same type pack. So we'll get into it and just see what we can learn today. Try to stay on the edges. See if it's anything around the connect. I might be able to cut around the connectors a little too gently if there's nothing right up against it. But there's the two screws. Still working away. Got a little ways to go. This board has been really challenging as far as showing on video as well as troubleshooting. These real fine leads compared to your normal leads, just absolute must in troubleshooting something this small with this SOT 23, a lot smaller, but as far as transistors, the SOT 23s are small. We'll get to them in a minute, but the really small dual transistor packages there, the complementary ones, they're small. So I figured I'd blow this up the best I could with a LaserJet printout. So at least you can see the components on here a lot better than me having distance to probe around. This is so much smaller. When I do talk about probing around on the transistors and troubleshooting, I will either have this one or this one. I took different pictures at different lighting. This one, you can see the numbers on the components better, but the glare is worse. So overall, we can just see the component footprint probably better with this one. Right off, looking at especially a surface mount board this dense. It's a very dense board. It's a lot of stuff going on here. A lot of different wires and connectors coming in, so it can be intimidating. To me, it still is, because I still don't have a full handle of the BMS and what's going on. But breaking it down by component, learning what we can learn, we can start seeing we got test points here to help us out a little bit. We got test point ground, test point 3V3, so there's a 3.3 volt. There's also a 3.3 volt here, and here they just plainly call it 3.3 volt. 3V3 here. I don't know why they designated that different, but they both read 3.3 volts with the power on. There's some other test points also that's really helpful here, where you start looking around, you see B1, 2, 3, 4, 5, 6, and I believe that says 7. Yeah, I'm verifying it on the actual board. Yeah, you can see it on this one. It says B7. And then it goes to over here in 9, 8, 9, 10, 11, all the way down to B14. And I noticed here with the battery pack plugged in and all the BMS individual cell wiring plugged in, that you actually can check across your cells from ground, or just going from the negative from the main battery terminal. And going up to B1, fully charged would be like 4.2 volts, and then 8.4 on B2. So it'll go up in series, it'll add up until you get all the way to your 56 volts. It was fully charged, of course. It also helped me to find out that I had some batteries that were imbalanced. Now that's after leaving it unplugged so it wouldn't discharge so badly, and just on its own they did get a little bit unbalanced. So then as I went across, without having to go across the cells themselves, you can go here where they're coming in. You can actually make sure it's getting all the way through to the circuit board and the vias. Your traces are all good. You're making sure that these solder joints here aren't loose, or at least they're making at the time you're testing. So I actually had all my battery voltages good. It was just a couple that I was concerned about. And if I went, for example, I think B3 was a problem cell. If I went from B2 to B3, it would show there as well that it was a low reading. I think I got 2.5 volts on that one. But looking at these test points, what I'm getting at is it'll help you a lot in troubleshooting. So instead of worrying so much about what I don't know, I tried to focus on the things that I could figure out or I did know. The little diode voltage test point, I'm not sure exactly what that is, but it must be important at the testing facility, at the manufacturing. The NTC-L and NTC-high, that is the negative temperature coefficient, or NTC, that's going on each connector or each half, because each excuse me, Each battery half has 7 cells. If you look, each one, it has its own little black, 2 black leads going to a, that is actually in, I would say PTC, but instead of positive, it's a negative temperature coefficient. And that actually is where they're going in on the connector. If you look, it's on the insides. So I checked there and I have voltage there, but I have checked the NTCs and they're both reading, I think it's 1.2K. It was about the same reading. I can verify that, but they were both reading about the same, so I wasn't that concerned about those. As we go through here, that also, we can tell that these little transistors across here, from Q1 to Q7, and from Q25 to Q31, I looked those up. And this is the arrangement we have. We see the emitter, you got emitter 1 and the base 1 and collector 1. And we also have the emitter 2, base 2, and collector 2. So it shows here that we have an arrangement in this SOT 363 package, which is a little unusual for me. I'm not that familiar with these, but after printing this out and seeing which one designates pin 0, I went through and actually checked every one of these, and they all seem to check okay. Doing the diode check. I'm going to bring this in. The actual leads itself are very hard to get to. So if I use this to go by and just check these little transistor packages, I got my meter on diode check. I got this turned the same way as it is on this sheet. Hopefully you can see that in the shot. So that'll help me go by where to put the base. For example, this is base 1, emitter 1, and collector 1. So I'm going to start off with the middle top. I'm going to put my negative on that middle pin. And across the emitter, make sure you can see that. Still don't know if you can see that. There we go. Diode, check there. There we go, across the collector. And now I'm going to reverse it and take the positive and put it on the bottom of the base of number 2. Because it's a NPN. There we go, I'm on the bottom. I'm now on that base. And there's my diode there. On the collector, now if I go to the emitter, getting hard to do on camera here. There we go, we got the emitter. So I went through, of course a lot easier off camera, but still time consuming. I went through and all 14 of these NPN and PNP packages, they all checked okay. So on those, I set those aside and started looking into Q10. And Q10 being a MOSFET has to pin out there for the gate, the source, and the drain. So it's turned, the way I have it here, it'd be turned like this, so the drain at the bottom and source in the gate. So without taking it out of the circuit itself, the main thing I did in diode check was just, since it does show that diode across the actual source and the drain, I actually just checked it with a diode checker. Drain the source, and it's open there. It shows the diode there. So that diode's in good shape and the junction's not shorted. So that's as far as I went with that one, except for a powered up check. I showed it going to, I at least showed the gate getting a pulse to it as well. So that was a quick check, and I went on to checking the Q11. Q11 is a BL marking. So checking this BL, which is actually Q11 and Q8. They're both marked as a BL or a NPN. It's going to be base emitter collector, pin 3 in the tab, being the collector. So with it being a NPN, I'm going to set this a little differently. I believe you can see it okay right there. So if I take the positive probe and put it right there on the base, and I go across the collector, there's my diode, and the emitter, and then there's the diode. I do the same thing over here. Diode, diode. I can reverse it as well. It'll just be the circuit resistance, whatever's in the circuit there, showing up there on the voltage reading, but to make sure nothing's shorted or showing low both ways. So I didn't see any issue with the BLs. Next up, I wanted to check the photo couplers. Photo transistor shows the pin out here, 1 and 2 being the diode, 3 and 4 being the photo transistor. So I don't know if you can see this from here, but this is pin 1 here and this is pin 1, so they are completely flipped around backwards. So with the diode check, I think this had a higher forward voltage. That's actually the reverse. Forward 1.0, go back over here now. Forward is the same, reverse is the same. And then the transistor side on this one, showing no impedance. Then there's the diode. There's the diode, then nothing, should be nothing. So there we go. So the quick checks on that checked out okay. I also pulled up the data sheet on U8. It's fine, real similar to the little SOT 363 2-in-1 complementary transistors. It's got a real fine pitch. It's even with these fine leads, it can be kind of hard to get on, but I do show a little bit on that on the oscilloscope, just trying to figure out if it does have an output, if you are getting a serial talking. I didn't know much else about this this particular chip, but I did want to show that I printed out some information on it if you're interested, and that way we can do a little bit of troubleshooting with that. Because other than that, we have the U5 and the U3 that are apparently microcontrollers, and I couldn't find the actual information on those. But this is a similar Fujitsu. It's a similar number that just shows it being an 8-bit proprietary microcontroller. And I believe the MB95F013K and the 95F012K, I believe they're real similar. It talks about them being the I2C UR. It's got a lot of different, which I know these aren't specifically these two, but just in general, it's the information about it being a proprietary microcontroller. Whether they're 8-bit or not, I'm not sure. So if anything failed in here, it's just done for me. Especially don't know how they're programmed, but so I focused on what I did know and what I could test. So that's why I wanted to show the components and go through testing them and show the findings of the test with you. At the oscilloscope now, I got the battery pack down below the board. I got the board and the board holder, hopefully in front of the screen where you can see them both on camera. It's going to be a little harder for me to get on these surface mount components like this, but I wanted to show that just tracing out and looking at the circuit, this Q9, and you can see it well right here. If I get on it with it blinking green, you can tell it's 1.17 hertz. You can tell that's the frequency of the green LED blink. So Q9 is putting out to the green LED blink. And if I press the button for the battery monitor, it switches to the red blink. And you can tell that Q9 no longer shows that frequency, but if I go to Q16, see now that it's back to green, it doesn't show. I'm gonna press it again for the red for the battery monitor. And now we see the frequency show up at approximately about 5 hertz. So Q16 is the one that's actually feeding that red, and it stops as soon as it goes back to blinking green from the microcontroller or the processor. So that's two little things troubleshooting and looking at. I know they're controlled by the processor itself, but everything seems to be okay with that. Like I said, it's very little information on the processors itself, but some of the things we do know, like U8 is a very small chip here. It is an 8-pin chip. It does show 1 in the top left corner, so it goes 1 through 4, 5 through 8. This chip was the one that's the real-time clock and calendar chip. It is the 85163. That is the 85163 we looked at. The pinout showing pin 6, 5 and 6 being the data. We got a clock output and then we got data. So I know the power supply is good to it. This is the pinout down here as well. We want to look at the serial clock input and the serial clock output. Actually, we'll probably look at that serial clock input, and then we got a serial data input and output. So simply just to see if this is putting out data to the processor for the real-time clock. And the only reason I was interested in the real-time clock aspect of it is this battery pack is kind of in-depth. The battery management system, where it tells you in the Ego book itself on the battery, it doesn't give a whole lot of information. It does talk about the pack and charging. It does mention that it will self-discharge after 1 month of storage. That it'll go to what they call a sleep mode and maintain a 30% of the charge capacity. So it doesn't mention there that it blinks green while that's happening. It does, however, mention under troubleshooting the battery end cap gets warm during storage, which is what's going on with this, and the power indicator flashing green every 2 seconds, which it ain't quite 2 seconds either, but it doesn't mention that anywhere else. It just says that it's actually in a self-maintenance mode. but evidently it will pull the battery down to 0, so there's something going on there. So the reason I was wanting to check this chip was because it is the real-time clock and calendar, so it's basically what's telling the processor the actual date and time and keeping up with it. So if we go, I'm going to change the scale here. I'm actually going to go down about 400, 200 microseconds. Bring the trigger level. I'm going to get on pin 6 here. Bring also 2 volts per division. It's got trigger level. Let's see, pin 6, 4, 5, 6. Boy, that is hard to get onto. There we go. We got some data. So we can tell, I got myself in a tough situation to make adjustments here scale wise. So we can tell that we're getting data. I do not know anything about this chip other than a few things on the data sheet I looked up. But we can tell we are getting data here. It is going to the processor. It's using the I2C bus. The processor also shows on the data sheet that it has that same communication ability. So as we check that pin and see that the data is getting to the processor, without knowing more about the processor, we know that this part and the 32.7 kilohertz crystal, it all must be working okay. The other thing I thought was interesting, the 3843, the actual U4 chip compared to U8, pin's a little bit easier to get to. This is the one that says it's a pulse width modulation controller. So looking at the pinout on it, it shows pin 6 should be the output. So it should be a frequency output. From pin 6 going to most likely this MOSFET here. It's kind of hard to trace it, but it does mention here that the output stage suitable for driving an N-channel MOSFET. So we see that we have an N-channel MOSFET. It's the FQT4N20L. So it's going to be Q10. So if we hold this in the same direction as we have it on the board here, we have the gate on the top right. It's gate, source, and the drain. We'll look at that gate after we look at pin 6. So we look at 1, 2, 3, 4, 5, 6. That's also pin 1. We definitely got some data there, but we don't have a very good scale. So let's go on our time. And I'm going to take our channel 1 actual vertical to 5. Yeah, there we go. 5 volts per division. We'll leave it about right there. So we look at that output from that current mode PWM controller. We see a pretty steady 101.8 kilohertz. So this thing's working right at 100 kilohertz on the pulse width modulation to control this, basically switch mode power supply. So it's taking the battery and it's actually controlling basically a switch mode power supply with this little transformer and this MOSFET working together. So looking at the data sheet and figuring out that's the output, we should then be able to take that same 100 kilohertz signal and see it on the gate, and we do. There we go. So that's on the gate of this N-channel MOSFET. Now one thing, if you can see it on camera, I hope it's obvious, it's got just a little bit of movement to it. If we zoom in just a little, and that's really not noise. It looks like that is the feedback adjustment. So as you can see that green light blinking, if I push it for the red, that should open up or widen just ever so slightly as the current increases. And there we go. We can even see it at the frequency of that red LED, how quick that switch mode controller is actually adjusting. Press it again. That's just looking at one pulse out of that 100 kilohertz signal, but the frequency itself's not changing. It's just the actual pulse width. So the power supply seems to be good. The rails are good. While probing some of the test points on these boards, I did realize after hooking my battery pack back up that I did have an issue with my batteries. As I was looking at some of these test points, and I would go to test point ground, and I would start with B1, which apparently means battery 1, and right now it is very low. I have some issues with my batteries right now, but 2.5, then battery 2 is showing 4.9, battery 3 5.6, and so forth. And this goes all the way through B7. Over here we see, if you can see that, it says B8. We can go on to B10 here. Shows 20 volts. There's 11, and there's 12. And we can go all the way down to 14, 30 volts, and that's actually the volts on the batteries right now. And the reason there's 30 volts on it right now is I actually have 30 volt supply going to it, because the battery won't hold up long enough to, while it's hooked up, to keep the LED blinking at this point. So as I was going through reading these measurements, I realized that I did have some issues, because you can go ground and go around and do them in series and add them up. You can also go across B1 and B2 and compare them individually. And as I did that, I realized that I had several cells that went way beyond the minimum. Some of them were below a volt. So with lithium, sometimes there's no return after they go that low. So what apparently happened was this battery management system, when it plugged up, it was pulling them all down equally. And apparently when I unhooked these from it after I got it all apart to see how they would hold up without anything hooked to them, just a cell sitting in storage for a few days, how they would do. And I did realize I had 3 cells that were faulty that I didn't realize with the BMS hooked up. So the BMS is actually a pretty good system. Now I wanna unhook the individual cells after showing that. I don't need that anymore, it's just in the way. I do want the power from the pack still. The full 30 volts right now coming up. As we look on this board, we have test point ground. We have some things here like 3.3 volts. It's a few things we can check. There's, I mentioned the individual batteries. Looking around, I saw that. This RT2 is apparently some type of resistive temperature device on the board. So we see up here it says diode voltage. It is a test point. It says diode voltage. It just shows 3.3 volts. I don't know exactly what the manufacturer was doing there. We have an NTC low, which just shows the 3.3 volts. That one actually is drifting, but it's just got the voltage on it. The NTC is actually the negative temperature coefficient device that's on each battery pack. The little black wires right there. Each side of the battery, they're saying like low and high, I'm assuming. There is each connector does have that temperature device going out on one side of the pack or the other. If you remember how that battery pack separates into two halves, kind of. So we see that checkpoint. There's also some other checkpoints that we don't really know what they are. Only the manufacturer has that information, but this one says test point 3V3, which usually means 3.3 volts, but why they put 3.3 volts here and just 3V3, I don't really know, but that's jam up. We have one here that says test point underscore DBG, and over here it's also a VCC for test point DBG, and I don't know what that is. It's showing 3.3 volts also. There's several here that show different voltages. That one's actually blinking with the light. So whether that's relation to actual current feedback, because I don't believe it's actually on the light circuit. One thing that was kind of interesting about the DBG test point, whether it has anything to do with it, I don't know, but if you look up DBG and electronics online, it shows that it's one of China's leading contract EMS or electronic manufacturing services. So I don't know if that's the company that made this board or not, but it is interesting that they do have that on there. Now when checking Q12, the Q12 component on this BMS, we notice it is a PNP complementary Darlington power transistor. I wrote the pinout down. It is the D-pack, so it's going to be base, emitter, and the pin 2 and the tab 4 will be the collector. It states that it is a 2 amp 100 volt. I'm in diode check mode still. If I go across, 1 is going to be your base, 2 is the collector as well as the tab, and then of course 3 is going to be your emitter. So I show my diode check there. It shows there. If I go to well, that's the first one so far that showed that a potential issue. I know in circuits sometimes you can't take it for 100% troubleshooting on checks, shorts, things of that nature. the values can be skewed due to, in this case, I'm not so sure this transformer's not in the circuit. I believe it's actually coming off this MOSFET, but it looks like part of the plane might be off on that side of the transistor too. I mean on that transformer off of that transistor. So what I'm going to do is I'm going to get the soldering iron and I'm going to lift this tab, and we'll check it without it being actually in the circuit. Okay, I'm back. Soldering iron. A little bit more. That is clear now. To make sure though, I'm going to go across the bottom pad, or also this C33. It's also with the pad. Alright, now it's no longer connected to that emitter. So now the emitter is not tied to here. The bottom pad is, but not the emitter. So now if I do a check, that is surprising. That's the heaviest current capability component on there, so I'm very surprised to see it shorted. That it could in one direction on the diode, it could show the 0.6 volts or so for that diode junction, but it should never show just shorted both ways for sure. So it's not just the diode. It could be the diode part of it, but it's not just the PN junction across it. So I want to see now if I plug this in, I still have about 30 volts on this battery. Let me verify that. If 30 volts are right at it, it should be enough to make that light blink. So with that leg unsoldered, it's not blinking the green LED. So if I take this meter lead and just short that out, oh, I saw the sparks. Yep, we're blinking green. I want to take it now and I want to see what the milliamps is across. I believe it to be milliamps. It does have a little arc into it, but I believe it's milliamps. Oh, DC. There we go. So we got it. Yeah, see it on there. Milliamps DC. There we go. That is showing 25 to 26 milliamps, and the green LED is blinking when that's jumped across that pad. So it's definitely coming from Q12. At this point, I'm going to order the MJD 117. It has been about 5 days. I have got in some of the MJD 117s. You can tell that it is a different manufacturer. The way the back is constructed, looks like the make looks to be the Motorola M there on the new one. Same D-pack. Get a little bit of chem wick now. Just a little braided wick, and get some of this up. Careful not to pull the pad from the board. I got a lot of the original solder off. I'm going to put a little bit of fresh solder on. I'm also going to put a drop or two of this rosin flux on there to help with heat and also the soldering process. Got it in place. I don't want to get it too hot. Unfortunately, these D-packs, you have to get that pad pretty hot. Sorry, it's a little hard on camera. I think it's got it back in though. Take it out and take a closer look. Upon closer look and testing, this component does check good. Well, I probably should have checked it on camera. Pretty sure I did not do that. Diode, 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 no short. So everything checks good. With that heat, the way I had to solder that D-pack is possible. I have ruined the D-pack just getting too much heat on it trying to get that pad to solder. So that let me know also that it didn't, apparently didn't ruin the transistor. I know I have about 48 to 50 volts on this pack thanks to being able to charge it up. As earlier with this drop power supply, I just hooked up to a known good charge battery and just letting that help me equalize this up to, I think I went up to 50 volts and it's been sitting here ever since. So the cells actually seem quite equalized, so the charge is probably a little low, but we'll plug this pack up, and first of all we'll give it the full pack of voltage and feedback. But we see right off the bat it's actually not blinking plugged up with power on it. If I push the button, hey, we get blinking red. Awesome. That does mean it's an issue with the pack, or saying it's low, but here's the thing, we don't have the feedback for the individual cells yet. So there's one. There's the smaller connector. That's going to each half of the pack, which also includes that negative temperature coefficient for each side and the individual cells feedback. So now we push the button. Drum roll. Whoa, we got it. That is looking very promising. So it looks like we were lucky enough so far we had no other issues on this main BMS control board. Man, I'm loving that. Well, this is the repair board going back together. Sure was a lot of work for that one little faulty transistor. But I know this doesn't have the potting now, nor does the connectors actually have the silicone seal over them either. It might be nice over time to actually have this covered back, but for me it's easier to work on, and I actually don't really get mine any moisture, so at this time I'm actually going to enjoy mine being this way. If I ever have to work on it again, and hopefully being a different manufacturer, I won't have trouble with that same transistor. Now if that same transistor gives trouble again, I don't like to re-engineer things unless I have to, but I would go with a bigger size in that same pack, just a high current carrying capability if it did give trouble, but probably just a manufacturing defect really, no longer than it lasts, hopefully not a design issue. Time and our other packs will tell. Awesome. We'll give it some time and see how it does. A few minutes later, the Ego battery is charged. Charged without any error. actually shows normal, so we'll put it in the one of the tools and actually test it out. Should also did a voltage check. We 57.85 volts. So this battery pack now does work well. Only time to tell how long it will hold up. I know the batteries did get pulled down below their acceptable level due to the fact that that board and that transistor being shorted was actually pulling it down too low before I actually caught it, was able to take it apart and unplug it. If you don't unplug it from that board, you have to monitor it very closely because it will get pulled down that low. I have taken off that serial number, as I had already done that earlier, taking off that serial number, so that's done per Ego's expectations. So it's, you know, time to tell, but it definitely still works good. Still shows good. I've used it a little bit. I'll just keep trying to use this battery more than I even do my newer and better batteries, and just test it out and see how it works. I hope this helped the community that may be having trouble with their battery. Just always remember, you're repairing stuff at your own risk. That's always something you have to take responsibility of. And Ego says recycle the battery and take the serial number off. Make sure you take your serial number off. And to me, what better way to recycle your battery than repair it and use it and get more years of life out of it, hopefully. So again, hope this helps the community. Hopefully helps with your battery. Please leave comments, questions. Let the community answer and comment any questions. A lot more people out there probably better than me to answer some of the questions about the BMS on the battery and things of that nature. So if you'd like to, give it a thumbs up, and thanks for watching.